Lesson 36, Confidence Interval Estimation for the Difference in Two Population Means. Example 2. Use the following sample data to estimate the difference between the mean head circumference of adult males and females. A random sample of 74 adult males had a mean head circumference of 22.05 inches with a standard deviation of 0.68 inch. A random sample of 76 adult females had a mean head circumference of 21.65 inches with a standard deviation of 0.66 inch. In this example, we're going to estimate the difference between the mean head circumference of adult males and females. To answer this statistically, we need to construct a confidence interval estimate. Since no confidence level was given, we'll use the customary 95% confidence. Now here we're going to estimate the difference between, and this is represented by subtracting, the mean head circumference, this is represented with mu, of adult males, which is one population, and adult females, which is a second population. So our confidence interval estimate will be for the mu1 minus mu2, where mu1 represents the population of males, and mu2 is referring to the population for females. Well, now we want to look at our sample results. When we're told that we have a random sample of 74 adult males, males being the first population, we know that our first sample size, N1, equals 74. And this first sample had a mean head circumference of 22.05 inches. Thus our x bar 1 equals 22.05. With a standard deviation of 0.68 inch, tells us that our Sx1 equals 0.68. In the second sample of adult females, we're told that the sample of 76 adult females gives us our N2, our second sample size, equal to 76. Had a mean head circumference of 21.65 inches, indicates that our second sample mean, x bar 2, equals 21.65. With a standard deviation of 0.66 inch, which tells us that our second standard deviation, Sx2, equals 0.66. So these sample results can now be used to construct our confidence interval. So we'll be doing a confidence interval estimate for two population means. So we use the following steps to guide us through the construction of our confidence interval estimate. Starting with selecting 1 minus alpha, the confidence level, we'll be using the customary 0.95. Next, 2SAMP-TINT is the command on the TI-84 calculator that we use to construct our confidence interval. But to do this, we need our sample statistics. So, using our sample statistics and the 2SAMP-TINT command, we do the following. We press Stat, arrow over to Tests, and then arrow down until the cursor is next to 2SAMP-TINT. And when the cursor is next to 2SAMP-TINT, we press Enter. Now for input, we have the actual sample statistics. So with Stat selected, we arrow down and enter in our x bar 1 of 22.05. And then we enter the Sx1 of 0.68. And then we enter the N1 of 74. And then we enter in x bar 2 of 21.65. And then we enter the Sx2 of 0.66. And then we enter the N2 of 76. We'll be using the customary 95% confidence, so our confidence level is 0.95. Pooled is no because we're not doing the pooled approach. And then we press Enter at Calculate to calculate the confidence interval. Under the 2SAMP-TINT command, in parentheses, is our confidence interval estimates. The first value is the lower limit L, and the second value is the upper limit U. Here, rounding off to the nearest hundredths of an inch, we see that we get 0.18 less than mu1 minus mu2 less than 0.62. So now that we've expressed our confidence interval symbolically, we can now express our confidence interval verbally. The difference between the mean head circumference of adult males and females is estimated to be between 0.18 inch and 0.62 inch with 95% confidence. Now, to further interpret this result, we notice that the 0.18 and 0.62 are both positive. This indicates that the first population mean mu1 is larger than the second population mean mu2. And since our first population was that of males, we could reach the following conclusion. Therefore, the mean head circumference of adult males is estimated to be 0.18 inch to 0.62 inch larger than the mean head circumference of adult females.